This is my black hole theory in 2018. It begins with the Schwarzschild metric, which of course has a singularity at 2m, coordinate singularity at 2m to be specific. And it is my position that at this coordinate singularity, time goes to infinity. This can be interpreted as time dilation of a single moment being stretched out to infinity, or it can be observed as time vanishing to zero when viewed from coordinate above the event horizon. So what you have is essentially just infinite time dilation at the event horizon, which is a singularity in the Schwarzschild metric. And below that is the physical singularity, which is located at r equals 0, and you have a stretch of space between the physical and coordinate singularity, and above that, of course, you have a normal gravitational field. Now my position is that the time going to infinity is not something that can be fixed by coordinate transformation, which is currently the methodology which is used. My reasoning for this is the law of general covariance, which states that physical laws cannot be affected by a coordinate transformation. So if I change the coordinates that I'm working with, it doesn't change the physical nature of reality. And the physical nature of reality is that the time coordinate will go to infinity for all observers. Now my position is reinforced by the metric itself, which inverts from coordinates above and below the event horizon. What I mean by that is that if I look at the metric for radii greater than the event horizon, what I will see is a metric which is represented as a negative, positive, positive, positive value across the diagonal. However, below the event horizon, the coordinates take the form positive, negative, positive, positive, meaning that between x0 and x1 coordinates there is an inversion, which is, of course, a space and time inversion. So space and time invert. Since there is an inversion of this metric, I would expect the curvature of the space-time to also have inverted. Now the Schwarzschild metric is spherically symmetrical. And as spherical symmetric, when you have a body which is spherically symmetric and you invert it, what you get is a pseudosphere. And it's no coincidence, in my opinion, that the cross-section of a black hole, coordinate singularity, perimeter, physical singularity, origin, is identical to the polar view of a pseudosphere, which is the inversion of a spherical body. When you flip a body inside out, you get a pseudosphere, which if you're not familiar with it, it basically has the appearance of a trumpet that goes in two directions. And the surface on these trumpet ends, it's negatively curved. It's a very interesting geometric shape. It has an infinite distance. It covers an infinite distance in either direction, but it has a finite surface area, which is neither here nor there for this particular discussion, but it's an interesting fact about a pseudosphere. And the pseudosphere, again, if you look at it from the polar view, and given, yes, this would be a hemi-pseudosphere, because you're only looking at half of it, but if the singularities are atop one another, they would appear as one singularity. In any event, if you look at it from the polar view, what you see is a coordinate singularity perimeter and a physical singularity center. So what you're looking at in a black hole is not a singularity which is composed of mass that's been crushed down to a singularity, because there are no forces which can stop the gravitational collapse. In fact, gravitational collapse is stopped by a space-time inversion. Once the space-time is inverted, the space, as mentioned before, becomes negatively curved. And as positively curved gravitational fields result in objects and matter and energies which attract one another, negatively curved space would, of course, result in energies and geodesics and matter which would repel one another. So nothing goes below the event horizon, and that space below the event horizon is actually repulsive of any infalling particle. Now with this scenario of nothing crossing the event horizon, you thus have mass collecting around the event horizon. Now this is problematic because that mass is going to be gravitationally, it's going to have gravity associated with it. So what you'd have in this layer of mass around the event horizon is that there would be collapses within that mass, and thus black holes would emerge from the mass attempting to collapse into the black hole. And then the mass around those black holes would collapse, resulting in new black holes, and the mass around those black holes would collapse, resulting in new black holes, so on and so on and so forth. This sounds very bizarre, and I did kind of develop it on my own and independently, but as it turns out, it is not outside the realm of physics. What I'm describing is called asymptotic darkness. As the energies of infalling mass increases, as it's pushed towards the event horizons of these black holes, it thus produces new black holes, and that's called asymptotic darkness. So it's not made up. Now, this means that the physical form of black holes is not one of just a singular, now I'm going to use a lone event horizon surrounding a lone singularity, but that it's a mass of event horizons and singularities emerging from one kind of blob of matter, if you will. And this model also incorporates all of the pseudospheres, which are below the event horizons, which have the appearance of strings. And this model of a black hole looking like a blob producing a bunch of gravitational strings, this is not out of the ordinary for physics either. Dr. Samir Mather has indicated a black hole model very similar to this, which is called the fuzzball black hole. So, the thought process for lone black holes is metric inversion at the event horizon, producing mass around black holes, not mass in singularities, producing asymptotic darkness, resulting in the fuzzball black hole model, or at least a variation of it. Being that fuzzball black holes are producing gravitational strings, the strings can interact with each other across vast distances of space-time. Now as they do, that's going to induce tension upon black holes at very great distances. Now that tension is going to pull black holes together in a dimension of space that we can't see. And that tension is going to result in the curvature of space around those black holes. And this is what I propose is the mechanism for the dark matter phenomenon. That what you're seeing in galactic clusters is nothing more than the interactions of what are interacting gravitational strings, or also called Einstein-Rosen bridges or wormholes. They're non-traversable because they're sealed on either end by ultra-dense black hole matter. But as the black holes are always producing these strings, two strings which come in contact with one another, or two black holes that make contact with one another with these strings, mean that those particular strings won't be immediately robbed of their matter, because they will be able to sustain one another. So this sustenance means that there's a competition between these strings to form Einstein-Rosen bridges and thus produce stable galactic structures across galaxy clusters. So that is the essentials of the theories that I'd like to present. The best example I have right now of evidence in favor of this model is that black holes across very great distances, black holes that are in the same clusters in very great distances, supermassive black holes at the centers of galaxies, all seem to spin in common directions. Each black hole shares the elements of spin of all the black holes around it. And this would, of course, imply that they can induce spin upon one another in a means that is not only not apparent, but not physically possible. It becomes much more obvious, much more apparent, and much more obviously possible if these black holes are connected to one another with Einstein-Rosen bridges. Another, I believe, evidence for the theory thus far is the fact that black holes appear to be the center of every galaxy in which we've looked. So this would imply that once you have two black holes, they will curve space in such a way that they will inherently gather galaxies around them. Because the black holes themselves don't have nearly enough mass to hold an entire galaxy in their orbit. But they would perhaps have the ability to curve space-time in such a way that galaxies would form naturally because of the added space-time curvature of an Einstein-Rosen bridge. Okay, the theory produces for me a model in which the Big Bang occurs in a very real and understandable sense. It doesn't invoke any kind of idea of nothing being before the Big Bang. In fact, it's quite simple to say what's before the Big Bang in this model. It's simply asymptotic darkness. What you do is you can imagine the entire universe collapsing into one black hole, and you'd have a universe which is comprised only of empty space and asymptotic darkness. If you simply take the space away, collapse that onto that single black hole, you have a universe which is nothing but asymptotic darkness. Now, asymptotic darkness is, of course, a bubble of space-time emerging in a negative curvature due to the extrinsic force of the mass around it. If you were inside one of those bubbles, you would see the bubble inflate and you wouldn't know where the force expanding the bubble would come from. And I think the universe formed in very much a similar process. That a bubble of space-time did open up, and that the extrinsic mass or energy around this bubble expanded until the mass within the surface reached beyond its Schwarzschild radius, thus meaning that the entire universe went from becoming asymptotic darkness into becoming basically particles left over of asymptotic darkness mixed in with newly created particles and space-time, which didn't exist before the Big Bang. So you can imagine a universe of asymptotic darkness, a bubble forming in that asymptotic darkness, which is being expanded by what would appear to be dark energy, which is actually an extrinsic force that forces the bubble to expand beyond the Schwarzschild radius of the energy within that bubble. As for the geometry of the bubble, I am uncertain. There are three obvious possibilities: flat, negative, and positive. I'm inclined to say that the space-time is negative, but there's no evidence revealed to make that argument. In fact, across the distance of the universe, we can see that space-time is remarkably flat. And this may be a kind of a flat Earth interpretation, that is to say, we've just got too small a viewing area to tell whether it's flat or curved. But I can't make an argument either way. In any event, the black hole model I wish to present is one in which dark energy expands a single bubble universe beyond its Schwarzschild radius. And finally, I also think that I want to posit that this Einstein-Rosen bridge method is not only the mechanism of gravity at the galactic scale, but it may also be gravity at the quantum scale. That quantum particles producing strings must curve space-time around them. And thus when you form a quantum particle, what you've done is you've made strings which, by their very nature, in the case of gravity, these strings are made of space-time. So perhaps if I can suppose that strings emerging within quantum particles are also made of space-time, that inclusion of space-time within the quantum particle curves the space around the quantum particle. This, of course, is very problematic because I can't tell anything about a quantum particle in terms of relativity. That's the whole issue with physics right now, is that you can't put general and special relativity to quantum mechanics. They don't They don't go together. You can't renormalize them. So you go a step downward and you uncover the nature of string theory, and then string theory diverges perhaps into gravitational and quantum mechanical physics. And that gravity in particles functions in the same way as dark matter gravity as we see it in our universe, but does so at higher dimensions. As the Einstein and field equations reveal, they become, this is something I've researched and not calculated myself, but they become Maxwell's equations in higher dimensions. I may be saying that incorrectly as well. But I have read that Einstein's equations do become electrical equations in fifth dimensional space. But the point is that regardless of whether you're talking about galactic clusters or you're talking about quantum particles, the mechanism for gravity is the same. It's the composition of strings which form particles that curve space-time around them. And that, in 2018, is the form of my theory.